In this video, we are going to work on verifying differential equations with a solution. When they say verify, just so you know, verify means that it should be right. So if you are working one of these problems, maybe on my test, exams, and it says verify and you plug it in and it doesn't work, then you did something wrong. If I don't use the word verify, it's going to say determine if it is. Okay, so we have a DE, and we have, here's my DE, it gave it to us there, and then a possible function, that y there. So first thing I'm going to do is looking at the DE, notice the DE has a y, and it has a y prime. So I need both of those. So y equals e to the negative x over 2, and we also need a y prime. So y prime, if I use the chain rule here, e to something, the derivative of e to the something is e to the something, but I need the derivative of the inside, which is a negative 1/2. If that doesn't make sense, we need to talk. We need to get you up on derivative rules and integration, because we're going to do a whole lot of integration in this class. Okay, so I have that. I have a y and I have a y prime. So what I'm going to do now is I write down my DE. And I'm trying to verify that that satisfies this equation. So I'm going to plug it all in. The derivative is negative 1/2 e to the negative x over 2 plus y, which was e to the negative x over 2. And we're wondering, and I always put a question mark here because we don't know if it's equal. We're trying to show that it's equal. That's verifying. All right, that multiplication up front is a negative 1. So I got negative e to the negative x over 2 plus e to the negative x over 2. Those are, I'm going to keep my question mark, even though it's pretty obvious. That is 0 equals 0. Just like checking an answer back in algebra, that's what we did. So therefore, that's what the 3 dots mean. Y is a solution to the DE. You need to make a statement. That statement is important. If you don't put that, you're going to get some stuff marked off because you just wrote a bunch of stuff down. Really need to start working on communicating mathematics to other people. So make sure everything's clear. I can read it. If you want to know how to work things out, I would work them out the way I did. Anything you add is not going to hurt. If you start taking things away, that's when you need to make sure you're still communicating that you can do the problem. All right, so that was A. We verified it. All you do is take the solution, find how many derivatives you need, and then plug them in and verify they work. All right, let's try B. All right, B here. So my DE is right here. I guess I got to highlight these things. There's my DE, and then the function itself. So let's work on the function first. Don't let the fractions throw you off. They're just fractions. All right. You can use a calculator for this class. The only thing you can't use in this class, and I'll write a list, is anything with a CAS system. That'd be a TI-89, TI Inspire with the CAS system. This will be checked as you go into the testing center. So if you're unsure, you can email me the model of your calculator and I can tell you a yes or no. It just can't do calculus for you. Okay, so I have y there. I'm going to take the derivative. So the derivative of 6/5 is 0 minus, all right, okay, so I have negative 6/5, a constant up front, that's going to stay. E to the something, the derivative of e to the something is e to the something, and then I get a chain rule. So I got a negative 6 over 5 times a negative 20. That's the derivative of negative 20, or negative 20t. And then I still have the e function itself. So I'm going to rewrite that real quick. The zero's gone. We end up getting 24 e to the negative 20t. Okay, so I write down my DE now. dy dt. And that's the same thing as y prime plus 20y. And they're saying it should be equal to 24. So I'm going to plug everything in. 24 e to the negative 20t plus 20 times 6 over 5 minus 6 over 5 e to the negative 20t. And we're wondering, is that going to equal 24? All right, so we got to do some distributing there. We already did that multiplication above. Both of those are going to be 24. So I got 24 e to the negative 20t plus 24 minus 24 e to the negative 20t. I'm still going to put this question mark here, even though it's pretty obvious those are going away. 24 does equal 24, therefore y is a solution to the DE. So we're just verifying by plugging in. That's all it is. Just like back in algebra when you started, and they would say, okay, 3x plus 7 equals 7. Check to see x equals is a solution. Verify it. Same thing. All it is now we're dealing with equations that have derivatives inside of it. All right, we're going to do one more in this video. It just looks pretty hefty. It's not too bad, though. All right, I'm going to highlight my DE so I can clearly see where everything is. There's my DE. So y is that crazy function here. All right, so y is c1e to the 2x plus c2xe to the 2x. All right, so I'm going to work down because we have to find two derivatives here. So I'm going to do dy dx first. Okay, so we get 2c1e to the 2x. That's the chain rule. If that's really like you're struggling really bad, we need to get some derivative practice in. So please let me know if you need extra help or you seek it out. Get back on your derivatives, get back onto your integration. They're not going away. All right, unfortunately for here, the second one, we have a product rule. So I'm going to take derivative of the C2 is going to stay on all of it because it's a constant. So I'm going to take derivative of x first, which is a 1. So I get C2e to the 2x. Plus, now I take derivative of the second, which is e to the 2x, which is going to give me a 2. C2x is still there, e to the 2x. We could rewrite this, I think, yeah, let's do that. Make our lives easier. We have noticed that we have e to the 2x in every single term. So I got 2c1 plus c2 plus 2c2x. We can't add all that together. We'll just leave it alone. All right, we have the first derivative, so let's go ahead and find the second derivative now. And I'm looking here. We get over here. We have a product rule that we have to do. Okay, so I'm going to do derivative of e to the 2x first. So we get 2e to the 2x. They're doing construction on my campus, so if you hear some buzzing, I'm really sorry. I hope it's not too loud. Unfortunately, there's nothing I can do. I can go complain, but I'll be honest with you, it's not going to change much. Okay, so derivative of this first, and then I keep the second. I know this it's kind of weird because the second is pretty big there. All right, now plus, and I keep the first, e to the 2x, and I take the derivative of the second. Now this is a constant, so it's 0, constant 0. This is a constant times x, just like the derivative of 3x is 3. The derivative of 2c2x is 2c2. All right, I'm going to shape this a little different because I don't want to have to plug that whole thing in. Notice that everything has an e to the 2x. So I'm going to distribute this 2 through there as I as I factor out e to the 2x on both. So I get 4c1 plus 2c2 plus 4c2x plus 2c2. That's this thing. I just went ahead and factored it all out. I think there is something we actually can add there. The 2 here, oops, that's my eraser. Here and here, I can add those together. So I got 4c1 plus 4c2 plus 4c2x. Okay, that was just the derivatives. I'm going to highlight those to kind of help see everything we need. This is y. All right, dy dx is going to be this term right here. And then the second derivative is this last term right here. Okay, so I'm going to write my DE down. I'm going to switch colors so we have some kind of contrast. So I got d squared y over dx squared minus 4 times the first derivative plus 4y equals 0. So we got to plug all that in. Okay, so the second derivative, we got e to the 2x times 4c1 plus 4c2 plus 4c2x minus 4 times the first derivative. So we got e to the 2x times 2c1 plus c2 plus 2c2x. Okay, that was the second, that's right here. So I'm going to underline these so it's clear where they're going. This was plugging in that first derivative. Let's, I can color code this actually. This was that. The green here was here. And then we have one more thing to plug in. We'll have this. So I am plugging that in now, plus 4 times y, which was the up there at the top of the screen, c1e to the 2x plus c2xe to the 2x. And we're wondering, running out of room, is this equal to 0? Okay, so notice everything has an e to the 2x, so I'm going to factor that out first. So the first one I got 4c1 plus 4c2 plus 4c2x. Okay, and then this negative will distribute to all three of those. I got minus 8c1 minus 4c2 minus 8c2x plus 4c1e to the 2x plus 4c2xe. My handwriting is getting horrible. I'm at the end of my iPad here, so please forgive me. xe to the 2x. And we're still wondering, is this equal to 0? Oh, we can take those e's out. So go back here, and we're factoring all the e's. So we get 4c1 plus 4c2x. There we go. That's better. The e to the 2x is out front, so I only have to write it down once now. I'm looking for like terms. So let's look for all our c's. So let's write this down. E to the 2x. Now I'm combining like terms. So c1, 4c1. I have another 4c1. That's 8c1 minus 8c1. Those are 0. Okay, so I'm going to write zeros on those. They're gone. And then I got c2. So I got 4c2 minus 4c2. Those are gone. I got 4c2x and 4c2x. Those are gone. Oh, those are positive 8. And then this minus 8c2x is a 0, meaning we have a 0 inside. It's kind of silly to put that, but this implies 0 equals 0. Therefore, y is a solution to the DE. All right, my advice on this, because that's a lot vegetable soup, right? Whole lot going on. This is going to be the case a lot this semester. There's a problem towards the middle of the semester, a technique that we work with series from Calc 2. If you don't remember, it's okay. We'll do a little bit of review right before it, and we'll be fine. But it's vegetable soup. And what I mean by that is there are tons of letters going on, tons of constants, and usually when you mess up, it will be because you just weren't careful enough. So my advice, if you don't want to do problems more than once, work slow.